Well, welcome back to another lesson in our Common Core Algebra 2 series. Tonight, we're going to introduce you to complex numbers. So let's get these written out in our notebook. Solve the following equations. So I've given you 4 here. 3 of them should be really easy to solve, and 1 not so easy. 1 of them you can actually solve in 2 ways. So let's take a look at the first one. X minus 1 equals 0. You might be thinking, wow, this is way too easy for Algebra 2. And it probably is, but we're going to solve it anyway. Basically, we're going to add that 1 over. So if I add the 1, I get x equals 1. Piece of cake. Number 2, solve for x. I can simply subtract the 1. X equals negative 1. Again, piece of cake. Number 3, I think you can solve this one 2 ways. The first way, I'm going to just subtract or add that 1 over and say x squared equals 1. What could I do to both sides to get rid of this square here? You've probably said it, we've talked about it recently. We're going to take the square root of both sides. That'll eliminate, but don't forget you're going to get plus and minus 1. Plus and minus 1. Okay, now I want you to solve this one another way. Let's rewrite it again. X squared minus 1 equals 0. This is called the difference, because there's a minus sign, of 2 perfect squares. So we could factor this to be x plus 1 and x minus 1 equals 0. And then when I tee it up and solve, I get x equals negative 1 and x equals positive 1, verifying that we should indeed get 2 answers. Okay, now for the ugly one. Number 4, x squared plus 1 equals 0. So I'm going to say x squared equals negative 1. Now again, how do I get rid of that square? I'm going to take the square root. But uh-oh, wait a minute, hold up. Can you take the square root of a negative? No, you're right. So this one can't get solved in our real number plane. Okay, this is not possible to solve. Let me go back, so I'm going to say no solution here. Let me go back and try to factor it. X squared plus 1 equals 0. Can you factor to x plus 1, x minus 1? Well, think about this. If you FOIL this out, you get x squared minus x plus x. Those would cancel, but then you get a minus 1. That's not what we have here. So you can't even factor this. That's not possible either. So I want you to bubble this one in, because this is what we're going to talk about today. What happens when you try to take the square root of a negative? All right, I want you to title this in big letters. Here is the big idea for today. X squared equals negative 1. Okay, and I want us to solve for x. So we're going to start by taking the square root of both sides, and we're going to rewrite it. So let's say x squared equals negative 1. Let's go ahead and take the square root of both sides. So this square and the square root are going to cancel out, and I'm going to get x. And here's where the magic happens, guys. The square root of negative 1 actually turns into I. And what this represents is an imaginary number. Okay, so the square root of negative 1 is now possible. You don't get a real number, and a real number is all the numbers in the world you've ever been used to. 5, 10, 15, negative 10, negative 20, the square root of 14. Those are all real numbers. But now we're introducing you to an imaginary number. So I want you to write this problem down. X squared equals, let's say, negative 4. We no longer don't have to say there's no solution. We can actually solve this problem. Let's take the square root of both sides. So the square root of x squared equals the square root of negative 4. The square and the square root cancel, so I get my x. Now picture this. If this helps, you can say it's really the square root of 4 times the square root of negative 1. And we know the square root of 4 is 2. And the square root of the number negative 1 is an I for imaginary number. So I now get x equals plus and minus 2i. Okay, so every time you take the square root of a negative, you now live in a whole nother world, the imaginary number world. Let's throw one more up there for fun. X squared equals 16. Negative 16. Okay, go ahead, take the square root of both sides and see what you get. I get those to cancel. There's my x. This is really the square root of 16 times the square root of negative 1. So that becomes a 4, and the square root of negative 1, remember, is the imaginary number I. Okay, so let's recap, and I'm going to give you another new term here. So we now know that the square root of negative 1 is equal to I. Now here's the second thing we got to get down for tonight. Watch this. What I want you to do, we're going to rewrite it, and I want you to wrap this side up and square it, and wrap this side up and square it. Now what happens? Those cancel, and negative 1 is equal to I squared. And I want you to box this in. This is the second big idea for them tonight. So we need to know that negative 1 is equal to I squared, and that the square root of negative 1 is equal to I. So obviously, if you know this one, it's easy to remember. Just square both sides. So I squared equals negative 1. All right, so we're going to add and subtract with complex numbers. You're not going to believe how easy this is. It's basically adding and subtracting like terms. So 3 plus 4i plus 7 minus 20i. Add the like terms. The 3 is alike with the 7, so 3 plus 7 is 10. And 4i minus 20i gets me a negative 16i. And you're done. You added and subtracted complex numbers. Let's try another one. Now we all know subtracting can get a little ugly, okay? But it's not any different if it's a real number or imaginary number. So remember, I'm going to rewrite my first term. I'm going to change subtraction to, you said it, I hope, addition. But if I do that, I then have to take that negative and kind of like distribute that through. So now this becomes negative 7 plus 20i. And we've talked about that many times this year. And now we'll just add our like terms. 3 and a negative 7 get me a negative 4. And a 4i and 20i get me a positive 24i. Okay, on our next piece, again, I want to rewrite these big ideas down for today. Okay, we just said that the square root of negative 1 is equal to I, and therefore, if you square both sides, if I square I get I squared, and if I square the radical here, I get negative 1. So again, big ideas, jot them down. I need to know that the square root of negative 1 equals I, and that I squared equals negative 1. So now we're going to multiply with complex numbers. All right, and again, it's going to be almost the exact same that you've multiplied before. We're just going to have i's now. So I'm going to FOIL this out. So first, outer. So 1 minus 2i, do the inners, plus 2i. Now here's where we have to be careful. 2 times 2 is 4, and that's going to make it a negative 4, and I times I is I squared. Okay, so now watch this. The middle terms are conjugates, or, negative 2i plus 2i, so those cancel. So it looks like you get 1 minus 4i squared, but that's actually not the final answer, because you know what I squared is. Go back to our big idea. I squared is really negative 1, so you need to substitute that in. So I'm going to say this is really 1 minus 4 times negative 1, which really makes this 1 plus 4. So this final answer is 5. Okay, so if I just blew your mind for some reason, you need to understand that I squared is equivalent to negative 1, and we're just substituting that in. Verify that negative 1 plus 2i and negative 1 minus 2i are solutions to this equation, x squared plus 2x plus 5 equals 0. All right, well, easy enough. We've talked about solutions all year. If this is a solution and I plug it in, I better get 0 as an answer. So let's just do it. Let's substitute it in. So I get negative 1 plus 2i squared plus 2 times negative 1 plus 2i plus 5. And if it's a solution, I should get 0 as an answer. Now, I'm going to have to slow down here because when it says square, remember that means repeated multiplication. I'm just going to multiply it by itself. Negative 1 plus 2i times negative 1 plus 2i. So I'm going to slow down and multiply that out. So FOIL. So that's going to get me positive 1 minus 2i minus 2i plus 4i squared. Now I'm going to distribute this 2 through these. So that's going to get me a negative 2 and a plus 4i. And then I have that plus 5 on the end. So my goal is, if this is a solution, I need all of this to come out to be 0. So let's see what happens. Let's see, I can add together the 1, the negative 2, and the 5. So 5 minus 2 is 3, 3 plus 1 is 4. And then I can put my i's together, so this is negative 2i and negative 2i, that's negative 4i and positive 4i. Those just all cancel. So I have 4 plus 4i squared, and I need that to equal 0. Now remember our little cheat sheet. I squared is really equal to, you've said it, negative 1. So I get 4 minus 4 equals 0, and guess what? 0 equals 0, so we know it's a solution, and it checks. Okay, so we have a solution to this equation. They want us to check a second solution, negative 1 minus 2i. So I'm just going to carefully plug that in. So I believe my equation was x squared plus 2x plus 5 equals 0. Sorry, I have to go back and double check. X squared plus 2x plus 5 equals 0, and I'm substituting in negative 1 minus 2i. So negative 1 minus 2i squared plus 2 times negative 1 minus 2i plus 5. All right, why don't you pause it, work it out yourself, and then compare and see if we get the same thing. Okay, so this is where the learning comes in. Pause it and see what you get. So I've got mine worked out, and you can just double check yours and see if it matched. I FOILed there, I put my like terms together, I distributed my 2, and obviously I'll let you find the rest and see if you made any mistakes. All right, evaluate x squared minus 4x when x equals 5 minus 2i. So again, basically I'm just going to substitute this into the letter x, with parentheses of course. 5 minus 2i squared minus 4 times 5 minus 2i. Okay, so again, squared is repeated multiplication, so I'm just going to write it twice. Foil that out, so I get 25, let's see, minus 10i plus 4i squared. And then I'm going to take this negative 4 and distribute, so that's going to get me a negative 20 plus 8i. I'm just going to clean it up and see what I get here. Let's see. This is going to stay 25. Those are going to make negative 20i. This is really 4 times negative 1 minus 20 plus 8i. Like terms, I can do, let's see, would you agree 4 times negative 1 is really negative 4? So I have 25, negative 4, and negative 20. So that's going to get me a 1. 25, and that's 24 if I subtract. And then I have negative 20 plus 8, so I would say that's a negative 12i. And that I can stay in your answer. The only thing that can't stay in your answer is the I squared, because we actually know that's negative 1. Now your next example is a little uglier just because we're substituting in this fraction. So evaluate 3x squared minus 25x when x equals 3/5 minus I over 5. So again, we'll just carefully substitute it in, use parentheses. Okay, so now we gotta watch order of operation. Remember your PEMDAS from middle school? Parentheses, exponents. So I'm gonna start here, and then I have to go to the exponent first before I can multiply or divide. So again, just to be clear, you have to square first, then you can multiply by 3. So I'm going to leave this 3 out front. I'm going to put a big bracket just so I keep things clear. And again, squaring is just repeated multiplication, so I'm just going to write that down twice. Close my bracket. And now, basically, when I distribute this 25, I'm going to picture it as an over 1. So when I multiply the tops together and the bottoms together, so I'm going to say that's minus 3 times 25 is 75 over 5. And a negative times a negative is going to make that a positive 25i over 5. Okay, so again, this piece, I just took this and distributed to the tops. and basically the 1 to the bottom. All right, so I'm going to clean up inside this bracket first. So I'm going to leave this 3 in front. Again, when I FOIL this, I'm literally multiplying the tops and the bottoms together. So that's going to get me 9 over 25 minus 3i over 25 minus the inside, that's going to get me 3i over 25. And now it's going to make it a plus. I times I is I squared over 25. And then I still have minus the 75 over 5 plus the 25 over 5i. All right, so again, I'm going to clean up inside the bracket. I'm going to leave that 3. Okay, these two terms can go together. So I have 9 over 25. That's going to make a negative 6i over 25. This I squared turns into a negative 1 over 25. Okay, now I can clean this up one more step. I'm going to leave that 3. I can put the 9 25ths and 1 25th to make 8 25ths minus 6i over 25. 75 divided by 5, I believe, is 15. 25 divided by 5 is going to be 5i. And now I'm going to take that 3 and distribute. Again, picture it as 3 over 1 and multiply the tops and the bottoms. So on top, I get 24 over 25 minus 18i over 25 minus 15 plus 5i. All right, and then you'll notice they have denominators of 25. So I could clean this up by multiplying these fractions by 25 over 25, just so I get everybody to have a common denominator. So 24 over 25 minus 18i over 25. Then I'm going to say this is 15 times 25 over 25 plus 5i times 25 over 25. Really, it's like multiplying by 1. So as long as I do it to the top and bottom, I can get a common denominator. So I'm going to have, whoops, I lost my pen. 24 over 25 minus 18i over 25 minus, what is that, 375 over 25 plus 125i over 25. And then I'll just group my like terms together, the terms with the i's. So 125 minus 18 gets me a 107i over 25. And then 24 minus 375 gets me a minus 351 over 25. And there you have your final answer all cleaned up. All right, I've got one last problem for us tonight. Now this looks like a monster, but I don't think it's as bad as it actually turns out to be. Express the following in a plus bi form. So basically, you'll love to see this because they're hinting at you should get an I in your answer. That's all they're saying, is you should have a number with an I in your answer. Whether it's a 1, a 2, or 3, we should get an I. So remember, a power is just repeated multiplication. So this really means I have 1 plus I times 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 1 plus I. Now you might be thinking this looks like a disaster, and you're probably right. I do have to write it out 6 times and multiply. But the nice part is, they're all the same thing. So I'm just going to multiply the first two together. So let's put a little bracket there and multiply those together. So if I FOIL, I get 1 plus I plus I plus I squared. So that's 1 plus 2i, and we know I squared is negative 1. So basically, that term just turns into 2i. Now, why did I say this isn't as ugly as it probably looks like? Well, picture this. If these two terms multiplied and got 2i, what do you think these two terms multiplied to? Hopefully you said 2i. And then, I'm sure you've guessed it, what do you think these two terms multiply to? 2i. So all you really have to do is multiply 2i times 2i times 2i. So let's go ahead and do it. 2 times 2 is 4. I times I is I squared. We can clean that up before we multiply that last one in. I squared, remember, is negative 1, so 4 times negative 1 is negative 4. Now I have to multiply by this 2i. So negative 4 times 2i is just negative 8i. So even though that looked hideous, it really wasn't that bad. I wrote it out the number of times it asked me to, I found just these two, and then I knew these were all going to be the same, and I just multiplied those three pieces together. Well, that does it for us. I just want you to remember the big idea. The square root of negative 1 is equal to I, and if I square both of those, I get I squared over here and negative 1 here. So I squared equals negative 1. Well, good luck, and we'll practice in class tomorrow.